Number one, find the missing side lengths of the triangles. These triangles are going to be special. 60 degrees tells you it's going to be special. That means this one is 30. And the two triangles that are special are going to be a 45 degree, 45 degree, 90 degree, and then a 30, 60, 90. So the 45, 45, 90, that comes from a square, and if you memorize the patterns of a square, you don't have to do any of the Pythagorean theorem or trig. So 30, 60, 90, that's an equilateral triangle. So 30, 60, 90, this one comes from the equilateral triangle. And this is half of it, so you need to draw the other half. The other half is the 30 and the 90 right here that get cut in half. So always over the 30 and the 90, that's where you're going to flip it. So it's going to be right here. And then if this is 1, that means this is 1, and this is 2, and this is 2. So it's a 2 by 2 by 2 triangle. And now to find the middle is always going to be this little guy, the guy that got cut in half, times a square root. And the square root that belongs to the triangle is square root 3. So n equals 1 square root 3. You don't even need to write the 1. M is 2. Then on number 2, there's your 30. So I'm going to flip it over the 30 and the 90. So it looks like that. That's square root of 3. That means this is square root of 3. That means this is just square root of 3 doubled, so you times it by 2, and that is it. You cannot times the 2 to the square root to the 3, because 3 is, it's not really a 3, it's a square root of 3, it's some crappy decimal, so you just leave it 2 square roots of 3. So this one is 2 square roots of 3 also. Now the middle, this y, to find y, you take the shorty, whatever it is, so it's the square root of 3, and you're going to times it by square root of 3, and now the 3 and 3 times together because they're both underneath, so that's square root 9, which is just 3. So y is 3, x is 2 square roots of 3. Number 3, okay, the 45, that one's a 45, this one comes from a square. And the other, this is half the square, the other half of a square is right there. And they're giving you the middle, the diagonal, and that's the hardest one to work from, is if they give you the middle. If they give you one of the outside pieces, it's pretty easy. Now the middle, it's 5 square roots of 2. You need to take the middle and you need to go backwards, so you're going to divide by square root of 2. And those cancel, and that means this is just 5 by 5 by 5 by 5. So remember the pattern of a square. If you got a square that's 10 by 10 by 10 by 10, to find the middle, you take the size of it and you times it by a square root. And the square root of a square is 2. So to go backwards, you have to undo the times square root of 2. You need to divide by square root of 2. Number 4 is another 30, 60, 90 this time. Flip it over the 30 and the 90, so it's going to be like this. That's 20, that's 20, that's 20, that's 10, that's 10. And to find the middle, it's going to be 10 times square root of 3. Okay, number 5, you kind of have two triangles put together. We need to find out how long this is, which is actually, that's a square. So first I'm going to start with the 5, and the 5, so that means this one's 10, and that means the middle is going to be 5 square roots of 3, so that means this is 5 square roots of 3, so this is also 5 square roots of 3, so the diagonal is going to be 5 square roots of 3 times a square root of 2, and these times together, and the 5 times is what's the number in front of here, which is just a 1, so 5 square roots of 6, that is the length of x. Okay, number 6, that's a square, you're 45, 45, 90, and they give you the diagonal, so work backwards. Divide by square root of 2, that means this is 8 by 8 by 8. That means this piece is 8. And there's your 30 and 90, so flip it over the 30 and 90. So your triangle is going to look like this. So this is 8, this is 8, this is 8. That means this is 4, and this is 4, which is what they want. And this piece, for fun, is 4 square roots of 3. Okay, now we got some word problems. What is the perimeter of a square if its diagonal is 10? So you got a square, and they're giving you the diagonal is 10. And you need to find the perimeter, so you need to add up all the way around the exterior. So diagonal is 10. You're going to go backwards. You're going to undo times square root of 2. So you're going to divide by square root of 2. And you can't have a square root on bottom, so times the bottom by square root of 2 times the top by square root of 2. And you have 10 square roots of 2 on top. On bottom you got square root of 4. So we got 10 square roots of 2 over 2. And these are both outside, so they play together. 10 divided by 2 is 5. So 5 square roots of 2, that means this guy is 5 square roots of 2. This guy's 5 square roots of 2. This guy's 5 square roots of 2. This guy's 5 square roots of 2. So the perimeter, you just add them all up. So 5 square roots of 2 plus 5 square roots of 2 plus 5 square roots of 2 plus 5 square roots of 2 is the same thing as 5x plus 5x plus 5x plus 5x. They are all like terms. So this is going to be 20x. So this is going to be 20 of those square roots of 2. So when you add, you just add like terms, and you just add the number in front. Just add the 5s. The x's are these square roots 2. Those are kind of like the units. They're inches, feet, miles. You don't add those. It's kind of what you're measuring by. Okay, the middle one. What's the perimeter of an equilateral triangle? So all three sides are the same. The altitude is 15 inches, so that is 15. It's 15 tall. So now we're going to work backwards. We are going to work backwards to the shorty. And from the shorty to the middle, you times it by square root of 3. So we're going to undo times by square root of 3. So we're going to take 15 and we're going to divide by square root of 3. So times the bottom by square root of 3 times the top by square root of 3. So we're going to have 15 square roots of 3 over square root of 9, which is 15 square roots of 3 over 3. Now those play together, which is 5 square roots of 3. So this is 5 square roots of 3. This is 5 square roots of 3. And if I double that, that's 10 square roots of 3. So the perimeter, if I add them all up, that's going to be 10 square roots of 3 times 3. Or 10 plus 10 plus 10. So it is 30 square roots of 3. Okay, the bottom one. 7-Eleven is 2 blocks east of your house. The school is 2 blocks south of 7-Eleven. What is the distance from your house to the school? 7-Eleven, 2 blocks east of your house. So here's your house. 7-Eleven, we're going to go east. That's 7-Eleven, 2 blocks. Then from 7-Eleven, we are going to turn and head south. So we're going to go south. There is the school. You went 2 blocks. What is the distance from your house to the school? So the straight distance. If you cut all the corners, that's what they want. And this is a square. So 2 by 2, that's half a square. If we go 2 by 2, so if we go the diagonal, it's going to be 2 square roots of 2 blocks. So 2 square roots of 2 blocks. solve each triangle, round your answers to the nearest tenth. Okay, now we're getting into the trig. So the trig, the SOHCAHTOA, sine, cosine, and tangent. So we can use that. We can use some Pythagorean theorem. You got to solve the triangle. So here's what you need. You need to find the measure of angle A, the measure of angle B, the measure of angle C, the length of side A, the length of side B, the length of side C. So 6 components. They give us 3. C is 90 degrees. And this angle A, that is side A. This angle C, that's side C. This angle B, that is side B. So little a is 6, little b is 4. I've got 2 of the 3 sides. I can do Pythagorean theorem, and this is the hypotenuse. So I'm going to do the little guy squared plus the little guy squared equals the hypotenuse squared. So 36 plus 24, no, 36 plus 4 times 4 is 16. So now 36 and a 36 is a 52 equals c squared. So square root, square root. Okay, now square root 52, if we punch it in, is not it's not a perfect square, but that's okay. They'll take decimals. So all these are going to be crappy square roots, which is no good. But if we're going to change it to a decimal, that's not bad. So to the nearest tenth. So square root of 52, we just found little c is 7.2. Okay, now we just got to find the angles. And the only way you can find the angles is to do the trig. So you need to figure out where you're going to mark your triangle. Mark it either from the A or the B. Don't mark it from the 90, so I'm going to mark it from A. If I mark it from A, this is the opposite, this is the hypotenuse, and this is the adjacent. And since I know all pieces, 7.2, I know all 3 sides, so all 3 of the trig ratios are going to work. It does not matter which trig I use, because I know all 3 sides. But if I want to do the 6 with the 4, the only trig that's going to marry opposite with adjacent is going to be tangent, or cotangent. So I'm going to do tangent. Tangent from A, and that is equal to the fraction. I'm going to put opposite on top, so 6 over 4. Now the trig is done, so now it's algebra. And if you want to solve for A, you need to undo the tangent. And the only way you can undo tangent is to do inverse tangent. So that undoes tangent, so we just have A equals, but you got to inverse on this side. So inverse tangent this one, and then that's calculator. So if I go inverse tangent, that tells me A is 56.3 degrees. So if A is 56.3, A and B and C have to equal 180. So I'm going to do 180 minus the 90 is 90. So 90 minus the 56.3, that means B is 33.7. Okay. Number 2, it's kind of the same, a little different. So we got to do the same thing. We got to find angle A, angle B, angle C, side A, side B, side C. And they give us angle A is 40, and angle C is 90. So A and B have to add and give you 90, so I know B is 50. Okay, and then this 11 is little a. Okay, so here we go. Let's mark it from the 40. If we mark it from the 40, this is my hypotenuse, this is my opposite, and this is my adjacent. Okay, I'm going to use 11. And I'm going to use 11 with my hypotenuse. So if we use 11 with the hypotenuse, that's opposite with hypotenuse, and that trig is your sine. So good. So we're going to use the opposite in the hypotenuse, and that is your sine. So now look, if we do sine from that angle, so from the 40 degrees, the fraction would look like this. The fraction looks like 11's on top and x is on bottom. Okay, now sine, whenever x is on bottom, that sucks, because you've got to get x on top. It's like an extra step. But sine is married to cosecant. So if we would do, instead of sine, if you do cosecant from the 40 degrees, that puts the hypotenuse on top and the opposite on bottom. And now this one is easier. So you can times, we're going to solve for x, so let's ditch the divide 11. Let's undo divide 11. So times this side by 11 times this side by 11. And on your calculator, if you punch in 11 times the cosecant of 40 degrees, that will give you the answer. So let me go grab an iPad. Okay, so if I punch in 11 times the cosecant of 40, that spits out 17.1. Oh, that's not a degree. 17.1, what did we just find? We just found x, which was the hypotenuse. So now we know this guy right here is 17.1. Now all we gotta find right here, so that was little c, 17.1. All we gotta find is little b. So let's use, if we use these two, adjacent with opposite, or you could do adjacent with hypotenuse, because now you know what it is. So two trig ratios are going to work. Adjacent with hypotenuse, or adjacent with opposite, that's tangent. So if we do tangent, if I go tangent from the 40, it's going to be adjacent, which is x, on top, which is what we like. We want the variable on top. On bottom is opposite. For heaven's sakes, tangent is opposite on top, adjacent on bottom. So I think this is going to suck. So opposites on bottom, opposites on top. That's 11. Adjacent is on bottom. That's x. Okay, now this time we could do cotangent instead, and that'll flip that upside down, but let's work one out where x is on the bottom. I'll show you it sucks. So if x is on the bottom, get x out of the bottom, so undo the divide x, so times this by x, and times this side by x. So times x divide x undoes, so you got this. X times the tangent of 40 equals 11. Now undo the times tangent, so I'm going to divide by tangent of 40, and I'm going to divide this side by tangent of 40 degrees. So times tangent divide tangent, that undoes, so now you got x equals, we're going to do 11 divide tangent of 40 degrees. Divide tangent of 40. And that is 13.1. So little b, this adjacent piece right here, is 13.1. Number 3 is just like 1 and 2, except for it gives you the specs and lets you draw your own triangle. So if you draw your own, the only thing that matters is C is the 90. So you could put A there and B there, it doesn't matter. A though, let's do it over here. So big A, angle B, angle C, side A, side B, side C. Angle C is 90, angle A is 55.6 degrees. So that is 55.6, and that means angle B, angle A and B have to give you 90. So I'm going to do 90 minus 55.6, and that is 34.4 degrees. So angle B, 34.4. Side B is 7.1. And side B was this one right here. Okay, now you gotta mark it up. So you either mark it from B or you mark it from A. So I'll mark from A. If I mark from A, this piece is my hypotenuse, this piece is my opposite, and this piece is the adjacent. Okay, now let's find, we gotta use 7.1. So your options, so, ka, toa. Let's use adjacent. So I'm going to use adjacent, and I'm going to find the hypotenuse first. I either got to find hypotenuse or I got to find opposite. So if I do adjacent with hypotenuse, I am drawn to the cosine. Now, cosine. Cosine from that angle, from the 55.6, equals, the fraction I'm going to set up is the A on top, 7.1, and the X, the H on bottom, we don't know. Okay, so since I hate having the variable on bottom, I'm not going to use cosine. I'm going to flip this upside down. So I want the X on top and I want the 7.1 on bottom. And secant is the one that does that. So if I do secant from the 55.6, now I'm going to solve for X. So instead of divide by 7.1, I'm going to times by 7.1, and I'm going to times this by 7.1. So 7.1 times secant of 55.6. And that gives me 7.1 times the secant of 55.6 degrees. Okay, I get 12.6. So that means this is 12.6. Okay, now I'm going to find the opposite. So I'm going to use the opposite with hypotenuse. And opposite with hypotenuse, that's sine. So now if I do the sine from 55.6, the fraction opposite is on top, which is X. That's what we like. On bottom is the hypotenuse, which is what we just found to be 12.6. Now times both sides by 12.6. So you get sine 55.6 times 12.6. And the opposite is 10.4. Number 4, these are the specs they give you. So if you draw your triangle, gotta make C the 90. This time we'll put A there, B there, doesn't matter. Side B is 4 and side C is 5. Okay, so here's what we've got. A, B, C, A, B, C. We got C is 90 degrees. We've got side C is a 5, that's hypotenuse, and side B is 4. If I want to find A, I can do Pythagorean theorem. So this is your hypotenuse. So you're going to do the little guy squared, add the other little guy squared, equals the hypotenuse squared. So 16 plus x squared equals 25 minus the 16 minus the 16. So we got x squared is 9. Undo the square. Square root. This is 3. So side A is 3. Okay, now mark it up. If I mark it from here, that means this is the hypotenuse, this is the opposite, and this is the adjacent. And because I have all three sides, I can use any of the three trig ratios. So I'm going to use sine. If I use sine, sine from A equals the fraction opposite over hypotenuse, so the fraction is 3 over 5. Okay, now these ones are actually faster and nicer. You have got to solve for A. You got to ditch the sine. So you've got to inverse it, and you've got to inverse this side. So if you do inverse sine of 3/5, that will give you the angle A. So angle A is what we just found, and it is 36.9 degrees. And now I'm just going to do on my calculator 90 minus 36.9, and it is 53.1 degrees. Okay. Next, we need to find the tangent of theta if the cosine of theta is 3/11. Okay, I'm going to draw my own triangle again, make it 90, and you need to mark it. So we'll mark it from there, put theta there. If you put theta there, this is the hypotenuse, this is opposite, this is adjacent. And the fraction they gave you was cosine, so cosine is adjacent over hypotenuse, so that means this one is 3 and this one's 11. And they want you to find tangent. Tangent is opposite over adjacent, so I need this piece right here. So I'm going to go 3 squared plus x squared equals 11 squared. So we'll go 9 plus x squared is 121. Minus 9 x squared equals 112. Okay, 112 is not a perfect square. So if you do 100 squared 112, it's a decimal. And your instructions, there's no instruction, but they'll say leave it as a radical. So leave it exact, don't round it, no decimals. So if we leave it exact, x equals exactly square root of 112. But that's unacceptable. You gotta simplify it. So 112, if we start breaking it down, if we do 112 divided by 4, that's gonna be 4 and 28, and that's a perfect square. Square root of 4 will come out. Square root of 4, that's 2. So 2 comes out. So on the outside we got 2. Now bust up 28. 28 is 4 and 7. 7's done. 4 is another square. Square root of 4 is 2. So you're going to bring another 2 out. And then on the inside, it's just 7. So 2 times 2. This piece is exactly 4 square roots of 7. Okay, now they want the tangent. So they want opposite on top and adjacent on bottom. So the opposite is going to be 4 square roots of 7, and on bottom, the adjacent is 3. So that is what they're after. That is the fraction they want. Next one, draw a triangle. There's my 90. And I'll put theta here, so that means this one's opposite, this one's hypotenuse, this one's adjacent. Tangent is opposite over adjacent. So we're going to put the 24 there, the 7 there, and now I need to find the hypotenuse. So I'm going to go 7 squared plus 24 squared equals c squared. So I know that's a 49. If we go 24 squared, that is a 576. And if I add those, that's a 625 equals c squared. Undo the square, so square root, square root. So if we square root 625, okay, that one's nice. That's a perfect square. So c is the whole number 25. So this is 25. And they want the fraction for cosine. So cosine is adjacent over hypotenuse. So they want the 7 on top and the 25 on bottom. Okay, now, story problem. Razzie wants to make a skateboard ramp. He has a board that measures 4 feet, and he would like to position it so that its highest point is 2 feet off the ground. So we're going to come up 2 feet off the ground. He's going to lay a board that's 4 feet. At what angle must he position the ramp with the ground? So there's your 90. It wants to know the angle. What's the angle? How many degrees is this ramp off of the ground? So if we mark it from here, that would be our opposite piece, and this would be our hypotenuse. So the trig that's going to marry opposite with hypotenuse is sine. So the sine from that angle equals 2/4 or 1/2. So now solve for that, undo the sine. So I'm going to inverse sine on the left, inverse sine on the right. So if I inverse sine of 1/2, it should give me 30 degrees, which I guess we didn't really even need to do any trig, because we could realize that was a special triangle. Oh, so 2, 4, so it used to be a 4 by 4 by 4. So awesome, 30 degrees.